Hi, this is the presentation of our final project. So the title of our project is WeMatchSports and the teammates are Onkar Apte and Mohit Gupta.
Hello. Let's talk about the goals of WeMatchSports. So we have built a web application that helps find sports buddies for the people. It also allows you to basically join sports specific public rooms, get matched with similar skilled players. You can even chat with the matched players. We have built a responsive, safe, and user friendly web interface. And finally, we have containerized the Django project in a Docker.
Our architecture is pretty simple. So we have clients which send requests to the REST API gateway, and then the requests are redirected to microservices. For messages, we have message encryption and message decryption, and for message queuing, we use Kafka. Finally, database which retrieves and stores data for the microservices. Interactions, we have front end which communicates with API gateway, REST API which receives and redirects clients' requests, microservices which perform specialized tasks. We have message queue which handles message efficiently. We have database which stores data and retrieves from microservices, and security layer which is responsible for encryption and decryption of messages and passwords.
All right, let's talk about the software components. So for the front end, we have used HTML, CSS, and JavaScript. For the back end, we have used Django. For the database, we have used MongoDB. For message queuing, we have used Kafka. For decoding the messages and hashing, we have used SHA-256 and Server Socket Layer to secure the system. For microservice communication, we have used REST APIs. For the containerization, we have used Docker, and we have also used some sort of techniques for monitoring and logging. Let's look at hardware components. So the first hardware component are the cloud servers. So the MongoDB is stored on a cloud. So it's a cloud storage device. So we are storing everything in the MongoDB. And the second part of the hardware components are the user smartphones, tablets, and computers via which they can access the WeMatchSports platform.
Coming to debugging, for code-based debugging, we use Python debuggers and VS Code extensions in the backend. In the front end, we use browser developer tools and the console. For RESTful API debugging, we use Postman to simulate requests and check and debug API endpoints. For database debugging, we use MongoDB Compass and MongoDB's Query Analyzer. So we check the data in the collections and ensure that the passwords and messages are encrypted.
All right, let's start with the testing then. Unit tests were used to test our views, they are used to test the functionality of our microservices. Integration testing, we did it via Postman. We passed on the data to our endpoints and tested their functionality. And finally, we did end-to-end testing using a tool known as Selenium to simulate user interaction with the WeMatchSports platform. We tested it for about 50 to 100 customers, and the website could handle the load easily.
Potential bottlenecks: number one, large number of login signups. Number two, invalid data from MongoDB. Number three, too many news API calls. Number four, misconfigured or unavailable partitions in Kafka. And number five, improperly configured Docker pods.
All right, let's start with the demo then, which is authentication. So we have containerized all the microservices into one particular Docker container. So let us build that first. Let's give it some time, and we can see that we do not have any sort of containers right now, but we do have a image created. So let's go to the container, and we can see that we do not have any sort of containers. Let us run this particular image at port 8000, and the image ID is particularly this. Let us run this. All right, so we see that the Docker container has been built, and let's go to this particular link, and let us start with the sign up first. So email ID, let's say it is test7@gmail.com. The past second game choice would be cricket. Let's say football, and let's just sign up. Now we have been redirected to login. Let us log in. test7@gmail.com. The password was 12356 @123. Let us try something else. So this is a wrong password clearly, and let's log in. So we see that we something is wrong. Let's go back to login. Let's try that again. test7@gmail.com. Let's log in. And here we have the dashboard for Michael Steve. Now that we are logged in as Michael Steve, we can see all of his data like mail, age, favorite games, and all of this data is coming directly from the MongoDB database that we have. Let's have a look at it. This is the MongoDB, and let's directly head to test7@gmail.com. So we see that the password is also hashed. So, and let's head back to the dashboard. So we see a profile icon here, and we can go to edit profile section, we can change some sort of things, like let us change his age to 25 maybe, and let us update the profile. Let us head back to the dashboard. Let us go to the database and verify. So we can see that his age has been changed to 25. So it's Michael Steve Boulder and 25. Yeah. Now in the profile section we have one more thing, which is public rooms. So if we go to public rooms, we see that there are many specific rooms specifically for one particular sport, like football, soccer, tennis, cricket, basketball, and we see that this particular player likes to play basketball. So if he clicks view, we can see some top 10 news about the basketball sport. So we leverage a news API for this and get top 10 headlines. And if we click on any one of them, we can be redirected to that particular news and we can check it out. Now we can head back to the public rooms and we can head back to the dashboard. And one of the main things of WeMatchSports platform is to find similar players. So this is the matchmaking. So let's click on find similar players. Now what this does is basically it shows the similar matched players that it has. So it uses cosine similarity in the backend. The similarity is based on the age, the city, and the sports that they have, and we can send some connections here. So I've sent it to Michael Jordan, I've sent it to Lionel Messi.
Messaging microservice is responsible for message marshalling, message queuing, and storing the messages back into the database. So for message encryption and decryption, we are encrypting the message using a secret key stored in the main project directory. For message queuing, we use Kafka, and for that we have two scripts, consumer.py and producer.py. So the name of a topic is determined by the prefix, which is a literal, and the ID of the user. So let's run the containers for Kafka and Zookeeper. But now let's look at the Docker desktop, and we see that the two containers are successfully running. So given that our application container is running, let's look at the chat functionality. So let's find similar players. Let's send connections to some of them. And I've already sent connections to many of these. So for example, here's a player named Michael Jordan, and we have already sent a connection request. So if we go to that account, we'll have a notification that we have one new connection request. And we can accept the connection request again. We click on find similar players and accept connection request for Michael Steve. Once a connection is accepted, we can chat with that connection. So in this display here, the messages are decrypted and then displayed. So let's type something. Let's type hello and send. So this message was at 7:08 p.m. Let's now look at the database. Let me refresh the collection. And we successfully see that the last message was received at 7:08 p.m. So this is the encrypted form, and this here is the decrypted form. So we can chat with any number of connections once we are connected, and if we have any pending connection requests, we can simply hover over this icon.